In this video, we will talk about the limit comparison test. So we were mainly talking about series that can either converge and diverge by kind of comparing it with a series that kind of looks like it. So in this case, we're going to look at a different series and see when it actually doesn't work. Because what we were saying was that if I can find some sort of series, so let me go back. So if I can find some sort of series that is convergent and I can prove that this particular series is less than or greater than this particular a sub n, then I know that this a sub n is also going to converge. If I know that this series is divergent and a sub n is greater than this new divergent series, then I know that a sub n, the sum of a sub n, is also going to diverge. So now let me show you when that doesn't work. So let's say you have the limit, this particular series, 1 over 3 to the n minus n. Okay, so one of the things that you might want to do is you want to compare 1 over 3 to the n minus n with 1 over 3 to the n. You might want to compare it. Okay, now you know that this series right here is convergent. So this converges by geometric series, which means that if this converges, then this should also converge as long as this is less than. But is that true? Is this really less than 1 over 3 to the n? Well, let's look at the denominator. I subtracted something from it, which makes this small. So when I divide this whole thing by 1, it's going to make it bigger. So actually, this thing, I'm not so sure that this is true. Okay, so that means that I've kind of violated the comparison test. I cannot show that this is going to be less than this other term. So I'm not quite sure. Okay, so if it was a plus, if this guy was maybe a plus, then yeah, maybe I can, it's going to be really easy. That's just simple. So instead, what we're going to do is we're going to come up with some other type of test that can try to help us out in trying to solve this. Okay. This is what we call the limit comparison test. So I'm going to just write it LCT for limit comparison test. Limit comparison test. Okay, so this is what the limit comparison test says. So suppose that the sum of a sub n and sum of b sub n are series with positive terms. Okay, so if the limit as n goes to infinity of a sub n over b sub n equals some constant where c is a finite number and c is greater than 1, and c is greater than 0, then either both series converge or both diverge. So, and this is depending on what b sub n does. Okay. A second to go ahead and stop the video if you want to go ahead and write this limit comparison test. So, so basically what you really want to make sure is that the sum of a sub n and the sum of b sub n, they're both positive terms, and just take the limit of the division between both of the a sub n and the b sub n. If this c term is finite and c is positive, then either both series are going to converge or diverge. So it really just depends on what exactly b sub n does. Okay, so let's go ahead and do this problem that we were trying to compare that kind of failed. So we were trying to figure out whether this series, the sum from n goes from 0 to infinity of 1 over 3 to the n minus n, diverges or converges. Okay, that's what we want to go ahead and determine. So we know that 1 over 3 to the n minus n, we are going to compare this with a b sub n. So this was a sub n because that's what was given to me. And b sub n is going to be equal to 1 over 3 to the n because that was what we were comparing it to. So by the limit comparison test, what we're going to do is we're going to take the limit of the division of a sub n divided by b sub n. So what we're going to do, we're going to take the limit as n goes to infinity of a sub n over b sub n. So what we're using here is we're using the limit comparison test. So let's go ahead and write down, we're using the limit comparison test. So this is going to be the limit as n goes to infinity of a sub n. Let me go ahead and write a sub n like this. Or let me write this as a sub n times 1 over b sub n. I think this might be a little easier to see. So you're going to have the limit as n goes to infinity, a sub n is equal to 1 over 3 to the n minus n times 1 over b sub n, which in this case is going to be 1 over 3 to the n. Okay? So now this is going to be equal to the limit as n goes to infinity of 1 over 3 to the n minus n times, we can just flip this around, which is going to be 3 over n over 1. And now we can multiply this out. So the limit as n goes to infinity of 3 to the n over 3 to the n minus n. Okay? And now all we have to do is just try to evaluate this limit. So we already know about L'Hopital's rule. So we're going to use L'Hopital's rule here. So we're going to write L'Hopital's rule. So we're going to take the derivative of the top and the derivative of the bottom. So the limit as n goes to infinity, the derivative of 3 to the n is just going to be 3 to the n ln of 3 divided by the derivative of the bottom is going to be 3 to the n ln of 3 minus the derivative of n, which is equal to 1. Okay, so if you forgot these type of derivatives, please go ahead and look at the derivative sheet that I handed out to you so that you can remind yourself of these types of derivatives, especially if you forgot. Okay, and now what we're going to do, we're going to go ahead and plug in infinity. So if I plug in infinity on the top, I'm going to get infinity divided by infinity minus 1, which gives me infinity over infinity, which is an indeterminate form. So this is what you're going to wind up with. So this is not what we want. So what we're going to do is we're going to do L'Hopital's rule again. So we're going to use L'Hopital's rule. So we're going to have the top part is going to be 3 to the n ln of 3. And then we have an extra ln of 3 divided by the bottom part is still going to be 3 to the n ln of 3 times another ln of 3. And then the derivative of minus 1 is going to be minus 0. Oh, and I forgot the limit part. Okay, so then the limit as n goes to infinity, you're going to have 3 to the n ln of 3 ln of 3 divided by 3 to the n ln of 3 ln of 3. This is going to cancel each other out, and you're just going to be left with 1. So the limit as n goes to infinity of 1 is just going to give me 1. Now because 1, so we just used the limit, we figured out this entire limit, 1 in this case is going to be finite, and c is positive. Okay, so by limit comparison test, since c equals 1 and is positive, and the sum of b sub n, so b sub n was this guy, 1 over 3 to the n. 1 over 3 to the n converges by geometric series, because we know that this guy is a geometric series and it converges, then the sum from n goes from 0 to infinity of 1 over 3 to the n minus n also converges. Okay, so one of the things that you had to make sure that you know is that there's a couple things. So the first thing is that you need to know that this b sub n is going to converge or diverge. That's the first thing that you need to figure out. And in this case, we know that this is convergent because of geometric series. Now all you got to know or figure out that this limit exists, is positive, and is finite. Okay, if you can show that this is convergent or divergent, doesn't matter, and you get a positive number, then this guy is going to do whatever b sub n does. Okay, that's the whole point of the limited comparison test. So let's do another example. Okay, so let's say, for example, we want to say the limit or the sum from n goes from 2 to infinity of 4n squared plus n divided by the cubed root of n to the 7th plus n cubed. Okay, so let's go ahead and try to use the limit comparison test here. So using the limit comparison test, okay, we have that we're going to try to compare this with another function. So we have 4n squared plus n divided by the cubed root of n to the 7th plus n cubed. Well, one thing that we can try to compare this with is just the leading coefficients, n squared over, this is going to be the cubed root of n to the 7th power, okay, which is basically n squared over n to the 7/3, and this just gives me 1 over n to the 1/3 if I were to go ahead and use some algebra with this. Now we know that this guy that we're comparing it with, well, this is just a p series. So because this is a p series, p is equal to 1/3, which is less than 1. So we know that this guy is going to diverge. So that guy diverges. So all we need to know or show is the division between these two. So we're going to divide these guys together. And if it gives me a positive number and it's finite, then this thing is also going to diverge. So that's what we want to figure out. So let's go ahead and figure out what the limit is. So we're going to have the limit as n goes to infinity of a sub n divided by b sub n. Limit as n goes to infinity. A sub n is just equal to all of this guy. So it's going to be 4n squared plus n divided by the cubed root of n to the 7th plus n cubed times 1 over b sub n. So it's going to be 1 over b sub n, which is on the bottom. In this case, it's going to be 1 over n to the 1/3. Okay, I can flip this guy over, so I'm going to have limit as n goes to infinity of 4n squared plus n divided by the cubed root n to the 7th plus n cubed times n to the 1/3 over 1. Okay, now what we're going to do is that I can go ahead and distribute this guy to each of the terms. So we're going to have the limit as n goes to infinity. Okay, so when I distribute that, I'm going to get what? 4n to the 7/3 plus n to the 3 over 3 4/3 divided by the cubed root of n to the 7th plus n cubed. Okay, and now what I'm going to do, I'm going to try to divide by the highest power. So I'm going to go ahead and just factor out the highest power. In this case, the highest power in this case is 7 over 3. So I'm going to take out n to the 7 over 3. And I'm going to be left with 4 plus 1 over n. Okay. And then on the bottom part, I'm going to take out a n to the 7th. And I'm going to be left with 1 plus 1 over n to the 4th. Okay. And the way that I'm basically doing this is I'm taking this 4/3 and I'm taking away 7 over 3. And what I'm going to be left with is just a negative 1. Okay. All right, same thing with this one. I take out 7 away from this 3 and I'm going to be left with negative 4. So that's why I put that in the bottom. Okay. And now notice what happens. So what happens is that you're going to have the limit as n goes to infinity of n to the 7/3, 4 plus 1 over n. On the bottom part, I can break this up as the cubed root of n to the 7th, then the cubed root of 1 plus 1 over n to the 4th. So I'm left with the limit as n goes to infinity of n to the 7 over 3, 4 plus 1 over n, divided by n to the 7 over 3, cubed root of 1 plus 1 over n to the 4th. Notice that the n to the 7 over 3's are going to go away. So all I'm left with is just this guy. So notice that if I take the limit as n goes to infinity, this guy's going to go to 0. This guy's also going to go to 0. So all I'm left with is with the 4 on the top and a 1 on the bottom. And 4 divided by 1 gives me 4. Okay, notice that 4 is a positive number, so c, which equals 4, is a positive number, and it's also finite. Okay, so what did that tell you? So because this guy diverges, okay, then this guy, by the limit comparison test, is also going to diverge. So by limit comparison test, the sum from n goes from 2 to infinity of 4n squared plus n over the cubed root of n to the 7th plus n cubed diverges. Okay? All right, and that really is all there is to this. There's many other different ways that I could have done this limit problem. One of the ways that I could have done it is dividing it by the lowest power of the denominator. I could have done that as well. There's many different ways that you can try to do this thing. L'Hopital's rule might actually not be the best way, but this is just a tricky way to do it. We kind of did a limit like this with sequences, but this is just one way to kind of do this limit problem.